Hello, everyone. Uh, my name is Artem Kholotkov, and today we want to present. Before presenting, we want to check if audio and video is showing. So please use chat or question section to give us any feedback if you can hear us and you can see my page. Starting slide. Okay, thank you very much. Uh, let's wait a few minutes more, uh, just allowing more people to join, and we'll start. Hello, everyone. Um, I think we are ready to start. My name is Artem Kholotkov, and today we want to show you the webinar and presentation we have prepared with Yoni Salo. We are members of mobile mapping support team. So, and today's topic would be Pfix as part of advanced registration. I will be doing some introduction, and we'll cover a few first slides, and then Yoni will take over the rest. First of all, this is first part of the advanced registration webinars, diving deeper into different registration workflows, since the Pfix is one of this workflow. We are starting today with presenting in order you understand what Pfix means and how it can be used. The goal is to understand what is the Pfix, position fix process, understand why and when Pfix could be used. We are expecting, since this is, we don't have time to present all the workflows in very details, so we are expecting from attendees to have some experience with our Trimble mobile mapping workflow, like basic understanding of post-pack processing and processing of the trajectory, and basic understanding of Trimble Business Center mobile mapping processing and registration workflows. Please note that presented workflow applies only for MX9 and MX50 data processing. For the older systems like MX2, it also can be done, but with different software. So this workflow applies only for MX9 and MX50. Few words about agenda. First section will cover Pfix theory. Second use case, we have prepared data set which can be used and will be used for hands-on part by Yoni. And also there would be few slides regarding the results of testing we have performed using the same tunnel data set. Actually, the third section is results evaluation, and fourth section is mobile mapping resources. We need to mention these for you. Okay, and at the very end, I hope we will have time for questions and answers. So please leave your questions in question section of the GoToWebinar pane. Okay, I will Yoni take over from this moment.
Yeah, hi. Hi from my side as well. Good day, good morning for everyone. Artem, can you hear me well?
Yes, we can hear you.
And you see my screen now, I think.
I do.
Perfect. Okay, let me start my presentation here. Okay, so yeah, my name is Joni Salo, and I will do the rest of the webinar here. Let's first jump into the theory part of this Pfix. So, of course, we need to now somehow explain you in the concept of the Pfix and what is the background of this and when and why would you use it. So what is Pfix? Here is a quote from Postback Manual. Position fix, Pfix, is a functionality that provides a means to aid the inertial solution with position information determined externally to the POS system. In other words, we could say that we are bringing information about where our trajectory should be, which is not collected by the POS system, but it's determined with some other way. There could be different ways to do this, but we have our own way of workflow, which works with the mobile mapping systems and the point clouds. So it's a postback functionality, but it's also connected to our Trimble mobile mapping workflow, which you will see later. Basically, today we are talking about one kind of registration. It's different from the registration we would do in TBC. But yeah, you will learn about this in the next slides. So the concept here is that we are looping positional corrections back to postback processing after we have found correction values in TBC, which are based on the difference between the original trajectory, point cloud, and control points. So from this perspective, it's a way of registration. But what is different is that we are actually bringing this correction back to postback instead of just correcting our trajectory in TBC. We are doing this because postback is more intelligent. There's different kind of filtering of different observations. So we are actually filtering this correction with IMU data, DMI data, and so on. So it's more intelligent way of registering data. Why would we do this? We would do this to give additional precise position input for the trajectory calculation. And when we would use Pfix process, it's not a thing or method you would use for all your mobile mapping projects. It's only for very special projects. We would use this when the trajectory solution is only or mostly relying on the inertial solution, usually because there has been poor or no GNSS observations available. So Pfix is something you would consider when you have really poor data set from the positioning and navigation and orientation perspective. If you're in the open sky, you have good base station and so on, you would probably not need to do this. You could just use the normal registration. Simplified example here. So let's start with a bad trajectory. So we are in a tunnel, there's an entrance and there's a exit of the tunnel. We have here a solution, trajectory solution in red. We have also these arrows, which are kind of, they mean the heading value, for example, which is drifting. So in this case, this is a bad solution because we are only relying on the inertial solution. We don't have any other observations to support that. So it's not very good. Then what we do, we add a Pfix, position fix, this yellow triangle here. And if this Pfix we add and the inertial solution agree, we get a new refined solution, which is in the green here. So the trajectory will go through this Pfix location. And what happens here is it will correct the position of the trajectory, but it will also correct the orientation of the trajectory. And this is one of the main things with Pfix, that we are able to handle, for example, heading errors with Pfix much better than with the registration in TBC. So just a simplified example, but what we want to say here is that you can really fix more fundamental issues with your data with Pfix than with the registration. Let's take a look at the workflow more in detail before I go to hands-on. So what we do always when we come from the field with our mobile mapping data, we always start first with positioning data and base station data. So there's two sets of navigational positioning data we take. We take those to PostBack and we process our first trajectory. Like usually, we just do our import of post data. We set our base station. We define some settings. We calculate the SBET, smoothed best estimated trajectory. And we take this trajectory information to Trimble Business Center mobile mapping model, where we use this trajectory as a foundation for point cloud georeferencing, imagery referencing, and so on. So in TBC, we take the trajectory and we also take the raw MX data, meaning everything else than the positioning data, meaning images, laser scans, and so on. In addition, we usually, and in this case, of course, we bring in some GCPs, ground control points. So points which we know very precisely where they should be in our coordinate system. Usually measured with total station, even leveling for heights. Some cases, RTK GNSS could be also one way to do this. And what we do in Pfix workflow, we calculate here based on this initial trajectory and GCPs and the point clouds. We calculate something called position fixes. What is the topic today? And actually, these position fixes are just a text file where we have a timestamp and a location where our trajectory should be in this timestamp. When we take this file, we take it back to PostBack. It's treated as additional input in the PostBack filtering. And in the end, oops, wrong way, we get a new SBET trajectory, which should be more precise than the initial one. Then after having this second, let's say, an iteration of the trajectory, we can go out from TBC with refined MX data. This means that our initial data is much better than before, but then we can do our all usual steps. We can still register it again. We can colorize it. We can do run-to-run registration. We can export the data to Trimble MX or Topo DOT or whatever. So basically, comparing to the usual workflow, we are just doing another loop between TBC and postback or other iteration of the trajectory calculation. Hopefully that's somewhat clear. You will see this on the hands-on part in more detail as well. A couple words about how we treat position fixes in postback. So basically one Pfix, one timestamp where we tell the postback that trajectory should go there, it's treated as with the same weight as one GNS solution. As with the GNS solution, with the Pfix, if the Pfix information does not agree with the inertial solution, so the IMU-based trajectory, within a reasonable expectation of an error, it may be rejected. So the Pfix should still make sense from the other sensor perspective. So you cannot have a Pfix which is saying that our trajectory should be 500 meters away because that is not within the expectation of an error. If both Pfix and GNS solution exist in the same point in time, they don't agree, so they're telling different positions, the GNSS solution might be selected over the Pfix because it probably will agree with the IMU inertial trajectory better. But if we use Pfix, we usually trust really Pfix more. So we want to introduce a GNS data gap, which is beginning before and ending after the Pfix. You will see this in the Pfix file later, that we are actually shutting down satellites before we introduce a Pfix and enabling them only after some time after the Pfix. This way we can make sure that the Pfix is considered and the GNSS data is not. Of course, many times you would use the Pfix workflow in cases where you don't have a GNS data anyway. But this way we can make sure that it's treated correctly. So maybe the most interesting thing here is that when you would consider using the Pfix workflow, we have listed some factors here. Usually your case would be a combination of these. First of all, if your GNSS data quality is very poor due to the following reasons, for example, long satellite outages, for example, a tunnel or an urban area, and you have a very heavy signal disturbance, so multipath from buildings or trees for a long time, for example. And sometimes you might get poor base station data when maybe too far away or bad update rate or bad or with gaps in the data or something like this. All these factors could lead to poor accuracy. Secondly, your inertial IMU trajectory might be drifting. It might be drifting due to the above, so it's not being supported by GNSS observations. So IMU has a tendency to drift if we don't have GNSS data. So that's basically you usually connected to the above tree. It could be also drifting because there's low dynamics. This could happen, for example, in railways where you don't have a lot of accelerations and turns, or slow speeds, another example. And IMU trajectory is more prone to drifting if you're using a lower grade IMU. It could drift and it will drift with even the high grade IMUs, but it just magnitude of the drift is much bigger with the low grade IMUs, and it will start to drift earlier. So usually your Pfix use case would be a combination of these. All right, let's look at the use case we have prepared. So we have this case we took as an example here. On the right side, you see a screenshot of the location of the data. So this environment where the data was collected is including 2 tunnels, 1 or 2 different tunnel pipes, but still it was collected forward and backwards. There's a lot of hills around this area, a lot of vegetation. So already from that perspective, it's a difficult environment for mobile mapping. The length of the run here is roughly 3 kilometers. The tunnel itself is not 3 kilometers. I think it's something like 1.5 or 2 kilometers, but still a bit longer than usual. We have ground control points in the tunnel roughly every 50 meters. That's good because we could test different intervals of Pfixes and so on. So we didn't really use all of them, but it was useful for us to troubleshoot, or not troubleshoot, but analyze the behavior here. One main factor here is that our base station was roughly 90 kilometers away, which is way too much. Usually we would say that reasonable maximum distance for base station is 20 to 30 kilometers away from your trajectory. So 90 kilometers is for sure too much. And all of this led to poor positional accuracy. So from the difference between our data and our ground control points was roughly 50 to 60 centimeters in the tunnel. And the goal, what we do here is bring data to high accuracy also in the tunnel. And how we do it, we use the Pfix process to correct the inertial solution in the tunnel. Right, let's go hands-on then. So I will show you how to do the Pfix processing with TBC and PostSpec. Okay. So let's start by checking the original TBC project. So I have prepared 2 TBC projects. One is with before doing the Pfix and second one is after applying the Pfix. Let's just quickly take, for example, the first control point here. So you see the tunnel starts here. Then we have control points along the tunnel. Actually, the naming of the control points is based on the distance from the first control point. So we have after 50 meters, then after 100 meters, 200 meters, and so on. So we have a 1.2 kilometers of data here with control points. Let's check here just quickly the first one, for example. I will just do a limit box here quickly so you can see it better. So let's make it bigger. All right, looks better. So the control point you see here, the triangle with number 0, it's there, but actually the data, based on the data, this point in the point cloud should be in this location. So roughly that's 50 to 60 centimeter difference in 3D. So based on that difference, we can calculate Pfix for this location or this timestamp. How we do that? We select our mission. This mission is called tunnel. We go to support. Oh, sorry, not support. We press F12. And F12 opens us a command window for TBC. This is kind of a hidden feature at the moment. So we need to type here generate Pfix. When I click this, TBC will open a new window here on the right side. That looks pretty much like the registration window, so the idea is the same. We add our control points. In this case, I will only add the first one here, and pick that. We have all the same tools as we have with the registration. I can activate limit box here to see the location better. We have all the picking methods. Let me make this a bit bigger. We have the intersected plane. Let's say if we would have a cross board checkerboard target or a reflective target. We could use road markings as well. In this case, because we are measuring this corner of this door here, we are just going to use the default picking method. Now we'll just try to snap roughly here on the corner of the door. I snap to that point. I get residuals in easting roughly 3 centimeters, northing 17 centimeters, and in elevation 35 centimeters. So that's our correction we want to apply on the trajectory. Next thing I will just do is press compute, and TBC will generate us the position fix file. It will take a couple moments per each Pfix. Meanwhile, I can show you something to do in TBC if you find this functionality useful and you find that it's cumbersome to always press F12 and type in the command. You can actually add this command to the mobile mapping ribbon here. So I right click on the mobile mapping ribbon. I press customize the ribbon. And this customization toolbar opens. I can create here, for example, new group under mobile mapping. We call it Pfix. And I can add this generate Pfix function, generate postback position fixes to this group. Press OK. And it should appear here on the very right corner of my ribbon. TBC is still working with the position fix file. It usually takes a minute or two for one Pfix because there's some mathematics happening in the background. Okay, now it's ready. So maybe took half a minute. So what TBC did here, it created a folder inside the TBC project structure called Pfix. And inside there, it just created a text file. And let me open that one. And I can explain what we have. So in this column, we always have a timestamp. These two first rows tell me that in this timestamp, we disable satellites. So we shut down satellites from postback processing perspective. Then we have the first Pfix. It's 15 seconds after we shut down the satellites. This is telling the postback that we have a position fix event, a dynamic one. There's a latitude, longitude, and ellipsoidal height here. Then we say that we trust this location to 1 centimeter accuracy. There is a correct frame applied. And actually this last number here is the GCP name. This was GCP number 0, so that's just 0, but you will see in the later example that could be something else as well. Now you might wonder why we have 2 rows here, because we only measured 1 location. That's because we have 2 lasers in butterfly configuration. That means that we get 2 observations of this location. So there are 2 close by timestamps there. So they're like 0.2 second difference between the 2 timestamps when we lasers saw this location. But this way we get 2 Pfixes per 1 location. Then 15 seconds after this, we enable the satellites again. This is a very simple example. This is just 1 location. You could, of course, have tens or even hundreds of them. Let me show you some different examples. Here. So for example, let's say we measured all GCPs what we had. We would have a file like this. So I think there's roughly, I don't know, 20 GCPs. So we have 50 something rows. And we are, because these GCPs are so close by each other, we only shut down the satellites in the very beginning and bring them back on in the very end. But we could also have a case where we have a kind of a gap in between. Sorry, I don't have an example here with that one. But yeah, let's say that if I would only have this Pfix at 1.2 kilometers and only the one in the beginning, the time difference between these two are so big that the automatic way of generating this file would enable and disable the satellites in between these two Pfixes as well. But yeah, you could have different kinds of these. You can actually also modify this manually if necessary. So you could take out disabling of the satellites or enable them in different time or whatever. If you know what you're doing, that's possible. So you don't have to stick with the automatically generated Pfix file. But in most cases, of course, it might be safe to keep using this one. All right. So what we do with this file, I will take the one we just generated. It's in my initial TPC folder, custom events. We don't rename it or anything. We take this copy. I go to my PostPack project folder. Inside there is a folder called extract, and I simply paste this file there. Now I have a PostPack project open here, and on this GNSS inertial processor window, we have this anchor icon here. And actually that's for position fixes and satellite events. If I click here, PostPack will automatically read that text file and show it here. So that's the same file we saw here, but it's read by PostPack in this case. Here you could actually as well modify things, so you could add more, you could delete something, you can enable, disable satellites, whatever you need to do. But I'm happy with this. I press OK. And now I can also show that I can see this Pfix 0 now 2 times because we had 2 per 1 location. We can see it here. Now I can simply start processing again. And in this case, the Pfixes would be taken into consideration. Here you see as well that we have the base station too far away. Also, PostPack is complaining about that it's too far away. So that's one of the reasons I explained in the earlier why the data was initially with quite a high offset from the ground control points. But yeah, PostPack can run there. That's okay. What I would do after PostPack is done, I would take the new SBET with this Pfix refinement. I could either just change the active trajectory file in my TPC project and then update scans, or I can just simply create a new TPC project, import data with the correct new SBET. Either way is fine. Also, from PostPack perspective, you can always bringing the Pfix file to existing project, or you can create a new project where you add the Pfix file, whatever is more clear for your workflow. And yeah, I think we can now jump into the project where we applied Pfix. So the SPET, in this case, the active trajectory file, is one where I used Pfix. And if I zoom into the same control point 0, what we sorry, a bit of lag. What we checked in the initial project, I can zoom in. I can do a limit box here as well quickly. We should now see that the control point 0 is fitting very well in this location, probably within a couple centimeters already. In this case, we only used this one Pfix, but I can also show that it's also affecting the control points a bit further away. So let's take this control point, which is 200 meters away from the first one. You can check the offset here as well. This is actually the top corner of the door, but in any case, you see even after 200 meters with one Pfix used, the data is fitting to control points very well. All right, that's the Pfix workflow in a simplified way shown. Hopefully it's clear for everyone. And of course, if you have questions, feel free to send them to us and we will check them in the end. Let me now jump back to the slides and I will show a couple more slides about the results. You already saw that it's really making an effect even with one GCP. We did some more tests. We tried, because we had very dense distribution of GCPs in the States, we could test how different intervals of Pfixes, how they affected the trajectory and the accuracy. On the blue, you will see, or let's start with the axis. The vertical axis here is the 3D misalignment to GCP, and the horizontal axis is the distance or GCPs, and the name of the GCP is the distance in meters. All the black triangles are measured Pfixes, and all the rest of these dots were used as checkpoints, basically. So the offset was measured in each point that you see with the black triangle where Pfix was applied. The blue line is with 100 meters interval of Pfixes roughly. So you see there's a black triangle roughly every 100 meters. And the red line is with 400 meter interval. So the black triangles are more sparse. But what is interesting to see here is that the blue line is clearly a bit better, but the difference is not super significant. This means that even with couple Pfixes in a tunnel, you might get rid of most of the offset, but more dense GCPs or more dense Pfixes you have, the better the solution will be. But if you consider the time you need to measure GCP every 50 meters compared to measuring one, for example, every 200 meters, you can save quite a lot of time if you just measure a couple of them and if you're happy with the results after that. To me, this would say that Pfix is actually a very powerful tool when you need to get rid of big offsets, big orientation misalignments and so on in bad areas. Also, we have another graph here. This is a difference graph between the original trajectory and the Pfix adjusted trajectory. Red line here is roll orientation. Green line is gray line here is pitch difference, and the green line here is heading difference. From this, we see that actually the orientation is also changed by the Pfix process. So for example, for heading, we see quite stable difference of not huge one, not in this case, not maybe even not really a significant one of 0.005 degrees roughly. But in some other cases, this might be much, much bigger, even in degree level, in very bad cases. So Pfix really is the way you could consider if you see big offsets to GCPs, big misalignments in the orientation. All right, that's mostly the content. Before we go to questions, which I hope there are, let's check a couple resources you can use to learn more about mobile mapping. First of all, I want to highlight the mobile mapping knowledge base. We have been keeping this up now for, I don't know, maybe 1 year already. It's getting quite a lot of information inside already, so that's really a good place to check first if you have a problem or a question or something about Trimble mobile mapping. So I would highly recommend to check this place when you need to know something. And if you don't find something here, feel free always to approach us in support. Also, we are putting a lot of videos to our YouTube channel. You can just go to YouTube and search for Trimble mobile mapping, and you can find most of these webinars and also some other nice tutorials, adverts, and customer testimonials and things like this in the channel. Additionally, all the webinars are stored in the Trimble Geospatial Webinar Center. So every webinar we have done in the last couple of years is stored here. You can watch them on demand, but of course for free. So you can go there, search for a topic, and maybe you can find some old webinar we already did on the topic. Then finally, a reminder from the support team, you can always reach us through imaging_support@trimble.com. Even if you might have our personal emails, we ask you to always contact us through this email because it will find its way to the whole team. That will help us to document and track cases for better support. We are able to transfer a case from one person to another easier and so on. So please always use that email. And one tip, if you use the product name in the email subject, like MX9, Postpac, TBC, Trimble MX, the case will find its way faster to us. So there's a couple different groups using the imaging support email. So there's some automatic ways we deal with the incoming emails based on the subject. All right. Thanks from my side. I hope there are some questions. We have still quite a lot of time. Artem, are you monitoring the questions? Do we have anything?
Hi again. Yes, I have a few questions. First of all, hi Yoni, can you elaborate how the 3 columns in the TXT set to 0.01 meters, how much you trust the Pfix affects the final trajectory?
Yeah, good. That's actually a very good question. So the question was about these columns. Yeah, the 1 centimeter was just pure. I think it was just a pure, let's say, decision we had to make. So we have to put something there. I think it's mostly about the picking accuracy. So we can pick the point for the GCP roughly within 1 centimeter accuracy. Of course, for Postpac, this tells that the Pfix can move within this 1 centimeter circle or ball or whatever you would say. So If that would be higher, then it would have more freedom, I think. Or Artem, what would you say?
Generally, this is the standard deviation along the northeast and down axis.
Yeah.
So you remember that slide when Yoni showed that postpack treats Pfix is like pretty much the same like one GNSS solution. And I would expect that this is accuracy of the point we have introduced to the postpack. So maybe the same like RMS value, certain evaluation in the same. So the treatment of this Pfix would be accordingly more strict or loose.
Yeah, I think so too.
Okay, I hope this clarified a bit the question, but very nice question. Second question I have here, with some of the postpack functionality now available in TBC, can you use Pfix in TBC only, or does it have to go back to postpack?
Yeah, very good question. To be honest, I haven't tried with the TBC integration yet. I think I personally would, in any case, use the standalone postpack because that gives me more freedom on the settings. So the TBC integration of postpack at the moment is for, let's say, easy scenarios, and this is not your typical default way of workflow. So I would personally still stick with the standalone postpack version. But it's a good question. I think we have to check how it's behaving with the TBC integration.
One more question just appeared. If you have two parallel tunnels side by side, can you pick both tunnels Pfix points, or you need to split that into projects? I can answer here. Considering that Pfix are linked with timestamps to the trajectory, so both tubes would have different time. So in parallel, of course, you can measure with the same menu, with the same project, just selecting ground control points and picking from another point clouds. So you will be getting the list with different timestamps. Most probably you will have the gap between tube 1 and first and second tube, because most likely the time between collection will be more than 30 seconds, a certain buffer we have mentioned. Yeah, and you could go with this list to the postpack. It will affect the same trajectory, same time, same project. So I don't see a big issue here. Yanni, anything to add?
Yeah, I agree with you. So it should be within one mission. There should be no problem to do it for multiple locations and runs.
First, I have one more. This has been a great webinar. Will it be uploaded to your website straight away? Probably not that straight away, but within, I would say, 1 day maybe, it will definitely appear there.
Yeah.
So you will find
it. It will be, usually we upload, so we did the same webinar already in the morning time in Europe. So you will either find the webinar done by me now or the earlier one where Artem was actually doing the hands-on part, but still the same content, and you will find it there sooner or later. And I think everyone who registered, they can use the link later to watch the recording as well, and you can probably share that to your colleagues as well.
One more question. Do we have time? Yes, we have. If you are correct in trajectories in TBC only, like you showed in the demo, how big a time block will you affect? Probably here is some comparison to regular TBC registration when movement of the one part of the trajectory will affect only certain section. Here it's a little bit different because we are implementing those Pfixes into the trajectory, into the postpac project, and combining it with raw data. So we cannot evaluate how big portion this will affect. For sure, we have controlled 15 seconds buffer before and 15 seconds buffer after the ground control point. So we know for sure that we are just disabling this section around the ground control point. So this part will be affected for sure. But out of the experience, for example, if we have, like in our example, we had a very poor conditions of the base station. It was far away, and along the entire trajectory, we had pretty much constant shift because solution was we were lucky having a float solution, and it was shifted pretty much the same along the entire trajectory. And we saw that even applying only one ground control point in the very beginning, the effect ended somewhere in the middle of the tunnel. So we saw even significant improvement, let's say 400 meters away from the trajectory, because global shift was quite big, and this shift was eliminated not only for the certain portion around the ground control point, but also distributed to the longer part of the trajectory. I hope this answered the question. Maybe Yoni, you have something to add?
No, I would say the same.
Okay. So we don't have questions anymore in our list. Please use last chance if you have any.
Yeah, and if you have let's say if you have a long question you need to formulate, you can also send us email to imaging_support@trimble.com. So that's also a way to ask if you like it that way.
Yeah, absolutely. Feel free contacting us with any questions. Okay, there is nothing appearing. Thank you for participating, finding time for this webinar. Really appreciate. Really hope that this would be useful, and you will be able to implement this to your workflow, and you will be more confident with further projects. So this is not just wasting of your time. Okay, probably we need to finish this session. I wish everyone good day, good evening, Good morning and have a nice day.
Yep.
Bye
Thanks
bye.
from my side as well. Bye bye.